Hey, welcome. Have you ever wondered how your favorite game just knows when you've won? Or how an app can tell if your password is correct? Well, today, we're going to pull back the curtain on that very secret. We are going to teach a machine how to think.
All right, here's our game plan. First, we'll get into the heads of computers to see how they make decisions. Then we'll check out the tools they use to compare things. After that, we'll build our first piece of logic with a simple if statement, give it a plan B for more options, and then it's your turn to put it all together.
So, first up, how do computers actually make decisions? What's really going on behind the screen of all the smart tech we use every single day?
I mean, really think about it for a second. A computer doesn't have gut feelings or intuition, right? It just follows instructions. So how in the world does it know that you've typed in the right password? What instruction is it actually following?
Well, here's the secret. It all boils down to this. Every single complex decision a computer makes starts with a ridiculously simple question that has only two possible answers, true or false. Is the password correct? True, you're in. False, you're out. That's it.
Okay, so let's move on to our comparison tools. Before our machine can answer those true-false questions, it first needs a way to, compare things. We've got to give it some eyes.
And these are the tools it uses. They're actually super simple. You've got your greater than, your less than. Now pay attention to this one. Equal to is a double equal sign. That's really key in programming. And finally, not equal to. That's literally it. With just these four basic tools, a computer can compare pretty much anything.
So let's talk about the simple if statement. Now that our machine can see and compare things, we can finally teach it how to act based on what it sees. This is where the magic really starts to happen.
The if statement is the most fundamental building block of decision-making in code. Just think of it like a one-way street. It basically says, if this one specific thing is true, then do this action. If it's not true, just keep driving, do nothing.
Let's look at some actual Python code here. This little program is asking a very simple question with our if statement. It's asking, hey, is the age this person entered greater than or equal to 18? And if the answer is yes, it'll print you are an adult.
And here's exactly how it plays out. The user types in 20. The computer checks the condition. Is 20 greater than or equal to 18? The result is true. And because it's true, that triggers the action, and boom, the program prints the message. Simple as that.
Okay, but what about this? What happens if the condition is false? Say a user enters 15. The computer checks, is 15 greater than or equal to 18? The answer is false. And since we only told it what to do if the answer was true, it does absolutely nothing. The program just ends. That's not ideal, is it?
This brings us to adding a plan B. Our program is a little limited right now. We really need to give it a backup plan for when that first condition is false. And this is where the amazing if-else statement comes into play. Just look at the difference here. On the left, you've got our old one-track mind code. But on the right, we've added one single incredibly powerful word, else. This creates a fork in the road. It gives our program a second path to follow if the first one is a dead end. This makes our program so much smarter and more robust. It basically guarantees that no matter what the answer to that true-false question is, the program has a clear instruction to follow. It's never left hanging. It always has an answer.
So here it is in action. The program checks if a number is 0 or more. If that's true, awesome, it prints non-negative. But if it's not true, it doesn't just give up. It automatically takes that else path and concludes, well, then it must be negative.
Let's trace the logic on this one. The user enters -2. The computer tests the condition -2 greater than or equal to 0, and that's false. So the program completely skips the code in the if block and jumps directly to plan B, running the code under else. See? Now our machine has a complete playbook for this situation.
All right, next section, handling multiple choices. If else is great for two options, like yes or no, but what about the real world where you have tons of choices, like assigning letter grades? For that, we need the if, elif, else super tool. I want you to think of this like a waterfall. Elif is just short for elsif. The computer starts at the top and checks the first if condition. If it's false, it flows down to the first elif. If that's also false, it flows to the next one, and so on. But the moment, the very instant, it finds a condition that's true, it runs that code and then stops the whole process. Now, the order of this code is absolutely critical. Notice how we check for an A first, marks over 90, and then a B. Why? Well, think about it. A score of 95 is also greater than 70.
By checking for the highest grade first, we make sure the program stops at the right answer.
This timeline shows that waterfall logic perfectly. Let's say the score is 80. Check 1. Is it greater than or equal to 90? False. Okay, moving on. Check 2. Is it greater than or equal to 70? True. The program prints grade B. And, this is the most important part, it stops right there. It doesn't even bother looking at the final else.
Which brings us to our final section, your turn to code. You now have all the essential tools in your toolkit. You've got if for one choice, if else for two, and the mighty if elif else for handling a whole bunch. You are now officially ready to teach a machine how to make some pretty complex decisions. It's your turn to be the programmer.
So here are a few missions for you and your newly intelligent machine. Why don't you pause here for a sec and just think about how you'd build the logic for each of these. Would you just need a simple if-else, or would you need a longer if-elif-else chain to get the job done?
So, let's recap everything. When you boil it all down, it comes back to just these 3 key words: if, elif, and else. With just these 3 simple tools, you can control the entire logical flow of any program, guiding it down whatever path you want based on simple true or false conditions.
You now know the fundamental secret behind how all machines think. You can build things that respond, that adapt, that make choices. So, the only real question left is, what decisions are you going to teach your programs to make next?